Change my background.
Good morning, Clark.
Nice, good morning.
Mhm.
Okay, for today's topic, we'll be actually covering cybersecurity best practices, uh, identity access management, IAM, SE Linux or App Armor, SE Linux for CentOS, App Armor for Ubuntu, configuring firewalls through Firewall D and IP tables, implementing logging services, backup, restore, and verify data. Let's try to touch upon them and see if we needed more time. So let's quickly start now. It introduces us to cybersecurity. It's basically the protection of computer systems and digital information from unauthorized access, attack, theft, or data damage. So this is very important in any organization, especially when you're storing important information such as personal information, IP, intellectual property, your algorithms or logic, um, and making sure that your resources are available to authorized user instead of unauthorized user. Okay. Next, we are then introduced with the CIA Triad. This is the very first triangle that you get to see when you're learning cybersecurity. You basically have confidentiality, integrity, and availability. Confidentiality just means that unauthorized people should not have access through information that it's private. If it's public, sure, anyone can access it, such as the stock market's information, the reported company, publicly reported annual reports, sure, anyone can access that. But as far as other stuff like employee records, student records for FERPA, health records for HIPAA, it must maintain its confidentiality. Integrity is when, let's say, I pass an information from me to another person, that information should not be modified. So if, let's say, I pass in my phone number as 425, it should arrive to the other users as 425 and not be modified by any middleman. Let's say it becomes 523, right? So you can easily do this through hashing and digital signatures. And going back with confidentiality, you can do that through encryption by encryption at rest, meaning not moving, the data is not moving, and encryption in data encrypted in transit, so while it's moving. For availability, again, authorized users should have continuous access to resources. And you could basically do that with redundancy and fault tolerance, meaning you just don't have one server, you might have a backup server and multiples of them, so that if one goes down, you can just reroute your users to hit the other server so that they can still access the same resources. Okay. IEC model. Oh, yeah. Yeah, the always intro for this one is not the Central Intelligence Agency. So, yeah. Oh, really? Authentication methods. There's tons of ways. Basically, we always use this PIN, password, and phrases, string of text. You guys know this already. Tokens or OTPs. Tokens are basically a physical or digital unique object you possess to verify identity. Usually, you can have like a card, uh, like to swipe in your inside of your computer, or let's say a USB token. Those are things that you can use. One-time password. Uh, these are the multi-factor authentication, which is kind of very annoying for the end user. When you log in, it sends you a number or whatever password, passphrase that you have to type. But it really lets your account or system be really secure. Biometrics. on the other hand, is not something, it's something that you possess, but it's more like part of your body, right? Like your eyes, your fingerprints, and I don't know what else they can use. Uh, and then voice recognition, yes. Radius and TACACS Plus, yeah, provides a service to remote access client. It's more secure and scalable. LDAP is basically a directory service protocol that runs over TCP/IP networks. You might encounter this more on maybe networking class. Kerberos centralized SSO single sign-on method based on ticket granting system can manage access control to many different services. Okay, anytime you have questions, please put it down in chat and we'll try to discuss and find out the answers. MFA, it's basically something you know, something you have, and something you are, and prevents unauthorized access if one factor is compromised. So this is very helpful if someone have guessed your password, right? And this one really adds a layer that it does prompt you to something like to your mobile device. And tokens as well, biometrics is more advanced. Must be different factor, not method. Okay. And as you can see this, you have your password and also a smart card that would allow you to access the server or system or resources. Privilege escalation, we've been doing this all the time, is active users obtaining access to additional resources that they are normally not allowed to. It's the usage of sudo, right? Look for behaviors that enable escalation of our attackers. So one pitfall is the overly permissive SUID and SGID. That's why we try to avoid using that a lot. There you go. Use principle of least privilege all the time. Okay, so this is just a definition of a term. Chroot jail is a technique by controlling what process can access on a file system by changing the root directory for the environment. New root directory, again, it would act as it has a new root, okay, and it will be called a jail. Process and children cannot break out of the jail, and process and children can access other parts of the system. So it's like they have their own system. Example, change root to home/user, right? What else? So this is good to basically determine, basically when you have an attacker coming in your system, you can basically just contain them in a jail, like quarantine them, right? So change root command enables you to change root with this example very easily. Chroot /home/user, and then also putting the bin bash so you can have a bin bash there as well. And this is how it would look like. And again, if the attacker comes here, let's say got hold on to your /lib, when it tries to go cd, meaning go up the parent directory, they can go up only as far as this one. So that kind of helps you not get attacked like outside of the jail. So it is also helpful. Let's say you're hosting up a web server. Let's say your www is here, and then they want to access more than that, and they couldn't, right? Let's see. Again, the one thing to note about change root is can't go to the rest of the system, and attacker would only see the jail as the root. Okay, not this one. Encryption. is basically a cryptographic technique, converts data from plain text into a coded or ciphertext form. And back in the days, we do use like, let's say, Clark would maybe become like, say, uh, you add 5 letters for each of them, right? So it's basically a ciphertext. But right now we do use different types of encryption algorithms to make it harder to crack. Okay, so if we have encryption to again encrypt it, protect it, we do have decryption to basically unprotect it and make it back into plain text. The algorithm called a cipher is responsible for conversion process, and only authorized parties with this decryption info can read the data. Info is called a key. Mm-hmm. Again, this is part of your confidentiality in the CIA triad. And as you can see, encryption, so you do have a plain text and you encrypt, and now you have a ciphertext, and from the ciphertext, you can now decrypt and the plain text. And this key is basically the key that would basically decrypt it as well. And let's see, the key is also stored and tied to your login credentials, this key. So let's say a CNGO user, right? It's gonna have that key as well to basically encrypt and decrypt stuff. So again, you use a key. Okay, you would use a key to basically encrypt and create a ciphertext. Okay, and again, you use the key to also decrypt the ciphertext back to plain text. So we do have Lux. Lux is basically a platform independent FD solution used to encrypt storage devices in a Linux environment. Uses DMCrypt subsystem on Linux, standardized format of encrypted devices. Let's see. So it's basically here's some of the commands. So front end to Lux DMCrypt. You have Lux format is Lux open, Lux close, Lux add key. It's basically creating those key stores. Um, so Lux basically means a Linux Unified Key Setup. And again, these are used for this encryption. Okay, supported by most distros. Again, generate manage key store. It can encrypt the entire disk, and it's also part of the Linux kernel. So here's an example for, like, say, crypt setup dash v looks format slash dev slash sda6. And let's see, hop into this one. Let's see if we can show an example. So as you can see here, when I do a listing of my partitions, you can see the type here as the file system, right? If this is encrypted with the crypt setup, you'll definitely have the crypto storage. It would say type crypto storage. Okay. And then, but basically before you even do that, I'll basically show you some of the commands that I don't need to execute really. First is, let's say you sudo umount, let's say dev sda2, something like that, like your chosen one. And then next would be you want to make sure that, let's say, this that you chose is no longer has any of this data, and the way you do it is basically with the shred command, and you can also point it to that one, the same one. Okay, that basically removes data there, and then once you unmounted and deleted what's inside of it, now you can start with your crypt setup, right? So you can do, let's say, crypt setup verbose, right? And verify and give it a passphrase so that it will prompt you, and the looks format so that you do have that encryption type crypto storage. Okay, what this basically would show you is you would be prompted with the passphrase, and then it will format to this and put it in an encrypted file system. It will then add a key to the username that you are currently using, and after that one, it still couldn't copy the data yet. It will, and you would now see if you do this again during this time when you executed this command, you should now see the crypto logs type. Okay, and now we did unmount, you unmount, you shred, you set up, right, the looks format, and the next thing you do now is basically you want to mount it. So let's say you mount dev SDA2, right? So you do something like that, and you mount, you have to mount to unlock it and format it, and now you can do again the crypt setup looks open, and basically the chosen partition, and let's say in the you created a folder called or directory called storage one, and make sure that, let's say the storage one is a virtual name, it enters a passphrase, and now when you try to see it again with the listing, the type would be now showing crypto storage, right? Also, don't forget, so when we mount it, you have to make the file system. So you do have to do mkfs.xfs/dev mapper, and this, let's say this one, it was the virtual name that you created, and again you have to mount that. You mount that with dev mapper, let's say storage one, and you do the mount storage one. Okay, and then that should be it, and it should be encrypted with these steps. So again, I just have to repeat. First thing you do, you want to list things, see the type, and you see the file system type. You unmount, you shred, you now do the first setup for the looks format. It becomes type, which should be becoming crypto looks, and now you basically want to mount. You can create the file system, you mount, and you check it again, and you now would see crypto storage. And this is how you encrypt data at rest, data that is not moving. Okay. Hashing is a function that transforms plain text input into an undesirable fixed length output so that, again, it cannot be easily read. Ensures process cannot be feasibly reversed. It takes a lot of computational power to reverse a hashing output. So it's called a hash value, or message digest. Input length can vary, but hash is fixed. Small change to input changes hash significantly. Used in password authentication. protecting integrity of messages and verification of integrity after transfer. And if you remember in your etc/shadow, you should see hashed password there. So here's an example. Let's say you have a message, you put it in the hash function, you get this message digest, right? And let's say you have a different message called keep this secret, and you have a function hash function. I mean, that one is going to process that message and becomes a digest. And again, one thing to note about hashing is that when you have the same message, it will create the same digest. Let's see, hashing. So, let's see, hashing. So now we'll go into network security best practices. I know we haven't touched into lesson 10, but we'll just go over them and solidify your knowledge once you are in the next course. So in this one, you enable SSL, TLS in all web server, configure your secure shell to disable root access, deny hosts that are not recognized, and consider changing default port associations. And for user access security best practice, protect the bootloader with password, protect BIOS with password, discourage use of USB storage devices. In most offices, I think I've experienced this, like you cannot just insert your own USB devices. Ensure UIDs aren't being shared. Consider level of PKI for authentication. Restrict access to cron. Disable control app delete functionality. Additional best practice, enable audit, so you do get to see audit all of the users trying to access resources that they should not have access to, or failed logins, stuff like that. Separate OS from data on other partitions and volumes. Regularly monitor the CVE database, and disable, uninstall, unused insecure services. So for the audit, basically what you need to do is make sure you also back it up in a different server, right? Because if the attacker got hold into that system, one of the things that they would really do is remove any traces they have. So they're just gonna delete the audit logs. So make sure you send a copy of your audit logs to another server. So guidelines, there's tons of it, but to make it simple, you do have to use the CIA. Consider requiring MFA, like requiring, it's not optional anymore. Don't use SUID, SGID. Place unprivileged processes in CH root jails. I'm very good with, let's say, web servers. You only restrict them to their www and not go outside of that. Encrypt sensitive data. Use LUKS to fully encrypt storage devices, as we showed earlier. And implement the best practices. Okay, skip this. Let's see this one. You can skip this one as well. Identity access management. Okay, it basically enables you to define attributes of identity, allow access management to make informed decisions, deny what level of access, role in company. So we've been using this as well, what you sampled in, let's say, HR department, right? HR people should not have access to some of the stuff, and as well as, let's say, the sales team should not have access to some of the stuff. So you can basically define them as individuals, in groups, and in roles. And most of the time, this is the first thing that you'd like to set up before you have users populate in your system. SSH authentication. So uses SSH uses password susceptible to password attack. Attacker can guess or crack password. So what we like to do instead is an SSH authentication with a public key cryptography because it's more secure. Users would create a public key, private key, and server has a public key. Server sends challenge that only private key can decrypt, and it can't be guessed or brute force. And maybe use something you have factor to require secure storage of private key. So you do have a private key and public key. So public key is something that we can just grab from a server, right? Let's see, SSH client. Let's see for the next slide. Okay, we can move on first and go back. Okay, so SSH authentication files in Linux. You can see this in your /home/username/.ssh. It contains key-related files for your SSH. And you have your private key, your public key, list of public keys, known hosts, list of public keys the client accepts. This one is the server, and config to configure your SSH settings. And these are the commands to generate key. You do the keygen to copy ID, and add private key to SSH key agent. Okay, so this goes about showing you how to keygen, and now basically it would ask you a passphrase, and then it will now be saved in your .ssh. This is using the root user, that's why it has the root here, and it will basically show a public key where it's saved and the fingerprint. And as you can see, it's using this SHA 256 encryption standard. SSH config files, so there's various ways what you can edit. Password, public key, port. You can change your IP address the SSH service listens on, so changing those IP address and port. You can change the root, chroot jail, allow groups, deny users, deny groups, permit root login. Okay, so there's that one. So again, most Linux distributions should already have this. SSH is basically a daemon, so it's running in the background, right? Background process. If you don't have it, you basically want to do sudo yum list SSH with a wildcard. Right? If there's nothing here, maybe you want to sudo list open SSH wildcard as well. Nope, does not see that. Let's see, systemctl status sshd. Oh, I do have it, so it's fine. And again, with this one, you would have both the secured server and secured client. Okay, let's see if we can get more info again with here. Let's see. Again, as you can see here, starting open SSH server daemon, listening on what port. Okay, port is, think of it as like the point of entry to your computer or system. Okay. Again, one thing to note, if your client is misconfigured and let's say your server is configured correctly, something can still go wrong. And if you basically configured your client securely, but your server is misconfigured, something can still go wrong. Okay. And as they say, let's say SSH port number is 22, which is the usual one, and let's say you want to change it to, let's say, port 300, because people don't know that. People just know the port 22 as the default, right? But they say that it's basically a security tier, so um, it just takes seconds for the attacker to see which port and what it is, so that doesn't really help. And if you now want to access the SSH config, we should go to slash etc/ssh. And just so you know, I basically changed to root so that I don't have to keep doing sudo. Okay, now I'm in my etc/ssh. I can basically look at in that part ls. So you would see ssh config, sshd config, and the difference for that is the ssh here on the left. The ssh config is basically your client, and then client-side configuration. SSHD is your server-side configuration. And now you do see the keys that we have here. We have the RSA key and the ECDSA key, ED25519 key, and if you only have until the key, it's basically the private keys of 3 different encryption key. If you do have the .public extension, it's basically the public key of the respective encryption. Encryption algorithm, yep. And then, so let's say your SSHD, we can basically check out the config for the SSHD. I'm already there, so I just do HHD. Now let's just put the full path so that you guys can see. Okay, and as you can see here, you see the port number. You can basically change that up if you want, and you do have to restart the service so that it takes effect. And then best practices is instead of deleting something that's default, you can basically do something like port 44 or something like that, right? And just exit and make sure you restart. And let's say if you don't want this anymore, you can just comment that out, right? And let's not save that. And again, once you configure this as well, say you change the port number, don't forget that you also need to configure your SE Linux, your app armor, and also your firewall, because again, you changed the port, right? So you have to kind of tell them that, hey, you have now to protect this different port where my SSH is serving. Okay. So also we do have SSH 2 already and versus SSH 1. The version 2 is more secure. version 1 is no longer secure and can be easily cracked or attacked. So SSH2 is basically protocol 2, and let's now check our server side. Oh, it's same. Let's see if it does show us though. Looks like it doesn't show the default protocol. But I think basically you can do something like this. So let's say you can just do something like protocol and then 2. And that would basically say that it's going to be using SSH2. And that one, when you basically define protocol 2, so any session that is connecting through SSH1, which is protocol 1, would be rejected. Okay. Oops, I'm just gonna go outside. So again, any changes that you made in your config file, you do have to make sure you start your Sshd. So again, the way you start that is sudo systemctl restart Sshd. Okay, it's just gonna stop and start the service again. Okay, so going back here and with the keys. So again, the private keys are those without the .pub extension, and the public keys are those with the .pub extension. And the public key is basically calculated from the private key. So you do need the private key to generate your public key as well. And I guess this was mentioned as well that there are times that you just have to be careful because, again, these are randomly generated. If you created this when your hardware doesn't have enough energy rate or entropy, they say, you might generate a number that's not random because, again, there's two ways you can get random. Is one is the random in the device holder, and then the random, which is relying on the software instead of the hardware. Okay, so to just have more like those hardware entropy, I guess energy to power up the hardware randomness, make sure that you have like been using have your system up and running for quite a while, right? So with that one, again, the lesson for that is basically don't trust the keys that's generated for you. You should basically just generate your own keys instead, right? Um, and now if we do want to create keys, let's start by removing all of our keys. So wildcard anything with the underscore key before it, and also wildcard after, so anything after it at the top .pub. So that quickly should delete it. Okay, now that we don't have keys, we want to generate both the private and public key, and the way we do that is basically sudo ss keygen. We want to generate, right? And let's say we want to create the RSA encryption. and we want to put that in etc sshd ssh, and this is basically the name. Let's just copy the previous one, which is this one, ssh host RSA key, and enter a passphrase, empty for no passphrase. We can leave this, and it shows you basically the fingerprint. Okay, this is the fingerprint, and says where it's saved. Okay. You also kind of do this as well when you're trying to connect, let's say, Windows or Mac OS, right? Your SSH to a system. You can basically create your keys the same way. And next one is, let's say you want to recreate your ED255, oops, ED25519 key, and just change it to ED25519 key, and then the other one should be CDSA. CDSA. Yeah, use a passphrase. So yeah, it just shows you the randomness. So if you're as a human, you can easily spot if this image kind of change. You would see that it's very random, but you can also verify that in another way, and you can see the like in a line format, right? Again, it's harder for you to verify if it's random or not, right? So let's see if we can just generate that again. And oh, so let's quickly delete that. Okay, let's try to delete and generate. Let's say just do RSA so it's easier. Let's do RSA. Okay, clear that up first. Let's do RSA, and let's delete that again, and let's do RSA again. You can see the image is different, so that kind of shows the human user, oh, it's random. And now, once you have your new keys, just don't forget to, again, restart with sudo system ctl start sshd, or restart, something like that. Okay, I'm not going to execute that anyways. And you can basically, let's say, sshd to username, add to a IP address to show fingerprints. Not going to show that. Okay. So that's how you generate a key, basically. And again, you can use this on your own. And we will still continue on, like, talking about some of the keys. Let's take a quick 15-minute break, and let's see you at 10 a.m. PST. We're now back. So let's spend like 3 minutes to do this. open up your CentOS, change your directory to etc/ssh, and delete the keys and regenerate them, and send in your random art image screenshot to the chat box below. I didn't realize I was talking already a while ago and I was not yet unmuted. Okay. I hope that was enough time, and let's proceed. So now, if you are a normal user and you want to figure out if the one you're connecting to is the right server, right? So first, you don't really need to distribute the public key, right? When, let's say, a client connects, meaning, let's say I connect to a server, I'll then get a public key, right? So what we need to distribute instead of the public key is the fingerprint, right? And let's see if fingerprint, let's do that quickly. So let's generate fingerprint quickly. So this is the fingerprint. Okay, so instead of the public key, distribute the fingerprint instead. Okay, so that fingerprint is something I can store, let's say, in my client, right? And where you would store it is basically, in your home directory. So let's go back to my home directory. And then I go, let's see first what's inside of my home slash, and then .ssh, if I do have it. Maybe I don't have that. Let's ls. Yep, so I don't have that, but I could just create, let's say, a directory .ssh, and I can create a file called like touch known host. And basically I can put stuff there like the fingerprints, right? Let's see if I can grab a quick example of what the known host looks like. Oops, let's see. So this is using the key scan and using the append to put it in the known host. When you see a period, it's basically a hidden file, and you use the -A option to open it. Yeah, I should have done that. But it did create, so maybe I didn't have it actually beforehand. Yeah, I didn't have it beforehand. That's why I was able to create it. Let me quickly go back to download. Nope. Okay, so just to, again, in your /home, you should see something like a known host, right? And basically what you want to do is, let's say you SSH key scan to, let's say, this IP address. And then maybe put that inside of your /.sh. And again, this won't work because I don't have a name or service with that one. Oops. Yeah, should be, yeah. But if you do have that access to that IP address, you can definitely add that to your known host with the append. So don't override, just keep appending. And let's say if you want to use the keys, yeah, if you can post screenshots, if not, it's fine. Because it's just an easy exercise and we can move along if you guys have done it. So again, another thing that you'd like to do is maybe this .ssh/known host. You might want to put that in your /etc/scale so that when you create new users, they already have the same known host, right? Um, that they do have the fingerprint of the servers that we trusted, basically. Let's head back. Yeah, sometimes Teams is kind of clunky. Even I couldn't send images sometimes. It's not sending it or loading it. Okay. Next stop, we do have the PAM. It's basically a pluggable authentication module. That was, if I have that correct, I think that's what it's called. Yep, pluggable authentication modules. Used by services like Kerberos, LDAP, provides common authentication for different apps and services. Authentication is streamlined, make it easier for admin to configure authentication policies. So developers can create their own PAM modules. So if you do want to configure it, the files are in etc. Again, we always talk about configuration. It's in etc and pam.d directory. So each PAM aware service has its own files. Okay. Includes directives. Directive format would be in the syntax. Okay. So this one is an example of a password policy directive. Password require pamcrack that live that so retry 5 times. So this one says it pertains to changing password. A result of the module must be successful with the required keyword. Module checks password against dictionary and gives users 5 chances to fail. TTY security, teletype security. Users can work with multiple controlling terminals. As we showed you earlier, even the same user could log into different TTYs, like just basically opening up a new console. Root users working with terminal can be a security risk. Anyone with root access can issue any commands. Yep. etc secure TTY, leverage by PAM to determine root access terminals. And then you can add or remove TTY number to give or remove root access to specific terminal. Okay, so this is basically securing TTYs. Now we're doing about the public key infrastructure. It would include certificate authority, certificates, software services, etc. And it can be public or private, implements asymmetric cryptography, encrypts, decrypts network data, often used to secure transactions of the internet. And the components, you do have the digital signature, which is the message digest. Again, if you put something, let's say a text to a hash function, it creates a message digest, and that is encrypted with a private key. Digital certificate is the fundamental concept of a component of PKI, and it will associate a credential with a public key and validate the holder's identity through digital signature and distributes public key. Certificate authority is basically if you have a client, you have a server, you have a CA in between that issues certificates and maintain keys, signs certificates so client can validate. Yeah. CSR is message sent to CA when entity applies for a cert and includes information that should go into the cert. Certificate signing request. Let's say this, yes, it has a diagram. Good. So you see that the certificate authority server would basically issue certificates. I think there should be a better image. CA server. Let's do client server only. So there you go. Oops, that's like open image. Okay, so again, both client and server has their own keys, right? The first process that would happen is client would request resource, but it's protected, right? So the server would first give it its cert or the key store, gives it to the client, and now the client, how would it verify? It will go to another server, a certificate authority server, to verify that certificate. Okay, and now the fourth process that will happen is client would present the certificate to the server, and the server also wants to verify it through the CA. So verifies the client cert in the CA server, and once it's good, a client can now access the protected resource on the server. Give you guys just a quick 1 minute maybe to look at this, maybe just 30 seconds. So now this poses a question of like the client or the server trusting the CA, right? So if this gets compromised, CA could be issuing fake certs. Okay, going back. OpenSSL, open source implementation of SSL and TLS. Secures data in transit. A while ago, we're doing encryption and data at rest, meaning not moving, for the this drive with the LUKS format, and I mean the LUKS encryption. This one, OpenSSL, is encryption in transit, okay, using cryptography as well. So in OpenSSL, you generate key pairs, generate self-signed certs from CSR, calculate hash value, encrypt data, manage key certs in a certificate authority, and more. VPNs, you guys have been using this, again, tunneling protocols to authenticate client and encrypt data, used all the time for maybe for to access your corporate resources, corporate system resources, right? And so that you kind of mitigate middleman, eavesdropper, or attackers. IPsec is an open standard, usually used in site-to-site VPNs. Provides authenticity, integrity, anti-replay. Operates at layer 3, so OSI model, they'll definitely go over that next course. Two modes of operation, you have transport and tunnel. Packets, contents are encrypted, header is not. Tunnel, everything is encrypted. And it's supported by many operating systems and network devices. So VPN client goes to a VPN server, and that would basically, the VPN server would then communicate to internal server. SSL, TLS, also used in VPN tunneling protocol, layer 7, OpenVPN. You can just skip this. Access and authentication troubleshooting. So users may not be able to authenticate for remote access. This is a usual case when you're trying to, let's say, even connect to a repository, right? So make sure you have the correct keys in place. Make sure the user system trusts the server, putting it in a known host. Make sure the user isn't violating policy. Check local authentication to see if it's the source of the problem. Inactive account, password protection. For the Kerberos /radius/ other stuff, ensure identities are configured properly and authentication services available over the network. We can skip this as well. Key pair. Can skip this for now. Maybe let's see if we can go back later with that one. Oops. So we do have a context-based permission. It's basically a permission scheme that uses multiple types of information. TACAX. Okay, TACAX. A permission scheme that uses multiple types of information about files and processes in combination to determine access. Defines properties for files and processes. Uses properties in conjunction to determine access. Basically, there's two types of scheme: Linux, SE Linux, and AppArmor. Mac, a model in which access control is by comparing object security designation and a subject security clearance. This is a mandatory access control and used by both SE Linux and AppArmor. We can go ahead. So with SE Linux, so it's developed by NSA and it just became open sourced after that one. So it was not open source to begin with. It's the default for your CentOS and RHEL. Enforces mandatory access controls, enables classification of information. So the context of what SE Linux has is the user, role, and type. So in the user, basically you can configure what the user can access, what objects it can access, right? It's not the same as Linux system user. Let's see for your roles, what roles can access objects. For types, group objects with similar security requirements or characteristics. So it's kind of repeated like in IAM. So you have roles, you have users, you have groups, and you would have user, role, and type, and you can basically see this with the ls-l capital Z command, right? Shows you the user, the role, and the type. As you can see, this would be user, role, and type _u _r _t. So you do have different modes such as disabled, enforcing, and permissive. Disabled is SE Linux is off, and it's like it's better off uninstalling it if you're disabling it. And this is a very important thing that you have to take note, because it might ask you, okay, SE Linux is turned off, so do you have any form of security? If you said none, that's wrong. You should know that the DAC would basically be enabled, and DAC is basically a discretionary access control. Okay, don't forget, when SE Linux is disabled, DAC would take over. Okay, enforcing enforces all SE Linux policy and processes that cannot violate them. And permissive, you basically allow violations rather than preventing. And with permissive, you could basically have, let's say you have an application and you want to test it, You basically want to do permissive and see if it goes beyond the boundaries that you're expecting it, and you can basically try to log the application trying to, let's say, access something that it should not, right? So, yep. So for testing, permissive is good, but you kind of want to do enforcing. So it is stored in etc/se Linux. All non-targeted objects run on DAC. Targeted subjects run on Mac. And you do have a bunch of commands to manage, see the status, set the enforce, get the enforce, set the bool, get the bool. Capital Z is showing the security context. With PS, you can do that as well. You can change security context of file with chcon, and if you mess around with it, you can basically restore it with restorecon, right? And here's an example of your SE Linux status. As you can see, it's enabled. Current mode is permissive. Another important part, I saw this in the exam, is basically asking where can you see the audit logs. So it's in SE alert -A varlog, varlog audit.log. Display all policy violations, display detailed information about each violation. And I think during my exam, there was one time I was basically asked to check different outputs of the command, and one of them is SE Linux. And at first, I kind of was only narrowed down to, oh, it's a violation. It might be an SE Linux violation. But when I check it, there's no violation there. So you have to check in other command outputs. Okay. Again, in the exam, you would experience something like, let's say this command and it's clickable, and when you click it, you would see the result of that command. So this was the important part, SE alert. Subject is denied based on policy, violations are unexpected. Let's see, use audit to why to make output more human friendly. Explain why violations occurred. Redirect entire log or grab a single event and pipe it to a command. Okay, let's see. So now let's do a quick concept test with the TAs, and then come back and let's do a quick follow along with the SE Linux, and just follow along and check the status if we can do. But for now, I'll let TAs take it away, and I'll get back to this question later with Kendall.
Thank you, Clark. Hello, everyone. Your first question for today is now available in the chat box. So go ahead. So your first question for today: which authentication method is based on a ticket granting system? So go ahead and answer it. Also, let's discuss which one do you think is the correct answer and why do you think so? Okay. So which authentication method is based on the ticket granting system? So today we have learned about the various authentications, about biometrics, about the OTPs, about Kerberos, LDAP, and we had also few discussions what LDAP is and why it is used. So yes, go ahead and answer it. Okay, so we have all 20 answers in. So let's take few seconds to get to a correct decision. Please go ahead and discuss. I would like to see what you guys think about it. Okay, so let's go ahead and see what the correct answer is. So the answer to this question is yes, Kerberos. So we have learned about various authentications today in which we have tokens and OTPs, which are the physical or a digital unique object, and it possesses to verify the identity. And this OTPs only stay for some time and then it expires. Then we have something called biometrics. Yes, it verifies the identity using the various physical characteristics, voice recognition, fingerprints, and retina scans. And then we have LDAP. It is a directory service protocol and it's a user authentication in which the username and the password combination is validated with a directory server. And this directory server is considered as a standard technology to store user informations and serve them to the application when, as and when required. And then we have our Kerberos, which is a centralized SSO method that is a single sign-on. And this is based on a ticket granting system. This is basically used for network authentication where the client authenticates with a third-party key distribution center and it gets a ticket from them so that they can access the various locations in the network. Also, these are considered more secure as it authenticates without a password. Okay, so let's go to the next question. Should be available for you. Yes, it is now available. So which file in your home directory under the SSH folder contains the private key for your SSH authentication? So today we have done a quick hands-on on this and I think all of you should get to the right answer. So go ahead, give us the correct answer and then discuss which one do you think is the correct answer and then why do you think so? Okay. So which file will contain the private key? You should be able to eliminate the wrong answers. Great. All right, guys, go ahead. 2 more to go. And that's it. We are complete. So let's see what's the correct answer. Yes, the answer to this is the second one. That is the file called id-rsa. So rsa.pub, it will contain the public key. Okay, before that, let's see what SSH authentication is. So SSH authentication works on a cryptographic, rather a asymmetric cryptographic algorithm, which generates a key value pair. So when someone sends you the data in an encrypted format, he will have the public key, and the person who only possesses the private key will be able to decrypt it. So this is what an SSH authentication is. So we will have both public and the private keys, and the location for them are as follows. .pub will have the public keys, and then ID RSA will have the user's private key. There'll also be a file called known hosts. This will have the public keys the client will accept, and authorized keys, they'll have the list of public keys that the server will accept. Okay, so any questions from any of these questions that we had today from the concept test? Okay, if not, then thank you guys. Thank you for participating. Over to you, Clark.
Thank you, Smita. Over to me. So before we head into App Armor, let's go ahead and quickly check our own SE Linux. Only for CentOS for now, because we guys have CentOS. Let's do SE status, if I do have it. Yes. So I'll go ahead and do it right now. I'll give you a quick 15 seconds to execute this command. And just familiarize yourself with what's popping up. Check that it's enabled or disabled, the mode, enforcing, the permissive. And let's see if we can set enforce. Let's check the man page for that one. As you can see, you can do 1 for enforcing, 0 for permissive. So let me just clear this up and do the SE status. Next is set enforce. And let's say I want it to be permissive. Again, you might need sudo for this one. Let's do 0. And now you see the current mode is now permissive. Again, you might want to use permissive so that you can test out application and basically log any SE Linux violation. Okay, now you set that one. You can also check with, let's say, get enforce. I just get the current mode, so get enforce. It's permissive. Okay. And if you do want to check the logs, if we have it, it should be here. And you can just tail that one out. So next that we do is basically get enforce to just check if it's enforcing or permissive. And then if you want to access your log, you just basically go ahead and go into var log audit, var/log/audit, and then the audit.log file, you can basically tail that one. At the bottom, it sees that the last one that I did, I can press enter more, so push that up. On the bottom part, it says receive set enforce notice, enforcing equals 0. And the next thing that you guys want to check out again is the ls-lz, which we did earlier. You can also do ps, I think, see that, dash, I think auxz, yep. So with the ps, before we were just using ps aux, right? We can do ls for this one, ps aux. If you use ps aux with the capital Z, uppercase Z, it will basically give you the label, which gives you the user, role, and the type, right? User system, role system, type is the kernel. You can say we can grep as well, which you shouldn't have. So HTTPD, we have SSH. We also have SSH. Okay, now it's another 15-minute break, and let's have an hour later again to talk about AppArmor and just a quick overview with firewall and IP tables, and hopefully touch on backups. It is definitely not enough to cover everything deeply, so and definitely you have to keep going back to the SE Linux firewall and backup. Those are one of the important topics. Let's see you later. Okay, let's see. We are now with the AppArmor. It's basically an alternative context-based permissions key and mandatory access control. Again, it's another Mac implementation for Linux package with Debian base and SUSE Linux distros. Provides same service as SE Linux, has a different approach. AppArmor is simplified. It uses paths, again, basically. SE Linux references with inodes, and determines how to control access, no types or domains, only profiles, okay? So with SE Linux, you have the user roles and types, and this one is basically profiles with the paths. And profiles should be located in etc AppArmor-D, and let's see. So you can bind services to have executable access. Path entries enable executable to access a file, like read, write, execute, link, etc. And these are your commands. As you can see, it's kind of the same with like enforce, disable, and complain is your permissive, right? And let's see, if I do have my Ubuntu server. Let's see if this Ubuntu instance has AppArmor included. Let's say AppArmor status. Sudo. So if you do have your Ubuntu instance open, go ahead and use the AppArmor_status command to get the feel of it. I'll give you guys 30 seconds, and again, it's AppArmor_status. I'll put it up here as well. So let's clear that out first. Maybe use a less. I'll give a quick 30 seconds. And you should see how many profiles are loaded or how many are in enforce mode. And if you want to see the files, yes, AppArmor_status. I'll show that again. And if you want to see the config files, again, config etc. But I don't think I have. Oh, I do have. So if you don't have AppArmor, let's see. This is Ubuntu, okay? Ubuntu. Oh, so AppArmor is installed and loaded by default. So if you're using Ubuntu, you should have no problem. Wait just a quick second. Just need to quickly respond to this. Okay, and then what was that? If you want to see the config files, it's basically located in your sudo/etc AppArmor.p. Oh, not sudo cd. Why did I do that? And ls. So you would see the config file here. And we can, let's say, less sbin.th client. Okay, I'll head out first to repeat. First, if you're using Ubuntu, go inside etc and AppArmor.d directory. May want to do ls to list. And after you've done listing, you can basically list, let's say, the sbin.dh client. And you can see such things as like capability net bind service. It binds it to the network adapter. Let's see more configuration, the HCP. Okay, so let's see app armor status again. Maybe it's through AA complaint. Let's see what it does. So if you don't have that, you basically want to do this. Yes. So you need to have, I think, a file path for that one. Path profile. Let's see if we can create one. How about if, let's say, test, and maybe a complaint that okay, that should be fine. No profile. Let's try this again and find something that we can edit. So let's say enforce mode. Let's try this one and change that up. So right now it's in enforce mode, right? Let's change that to AA complaint, then sbin ph client, sudo. So when I now do armor status, app armor status, I should now see sbin in complaint mode. Okay. Again, first what I did is I app armor status and see the list of profiles, right, which are in enforced or in complaint mode, and I basically use AA complaint to change that. If I want to go back to disable that, maybe AA complaint sbin ph client. No, sudo AA, sorry, disable /sbin client ph client, sorry. Okay, so that disabled it, and I should see it nowhere, right? And if I want to put it in enforce mode, I can just go do enforce, and I should see that again there. Okay. SE Linux App Armor, SE Linux CentOS, RHEL, App Armor, Debian, Ubuntu, SE Linux user, role, type, App Armor, path, profile. Let's see. Can just move on ahead with this one. So firewall. Basically, device that protects system or network from unauthorized access or blocking unwanted traffic. firewall is basically something like this, such as this one. Small image. Yeah. Basically just putting up a wall and allowing just certain things to pass through you. This is the inbound, right? And again, firewalls like this. So it can basically allow or deny based on rules. Usually have logging and altering features. It has three generations, which is the packet filters, stateful firewalls, and application layer firewalls. Packet, basically based on packet attributes, so you can filter that. Stateful can identify past traffic that is related to a packet. It can view entire conversation of a transmission, such as the TCP/IP handshake. Application firewall, these are now application layer traffic, which is more commonly used, such as the, let's say, HTTP or FTP traffic. So it looks like that. So let's say you have a web client that can, a web server with a firewall, let's say, that only permits port 80 traffic, which is, let's say, web, and all other traffic such as FTP will be blocked, so it does not go through. So access control list feature, again, so firewall also have access control list, and you can allow deny based on, let's say, the IP address or the ports or the protocol, right? You can, again, deny incoming traffic from, let's say, a port. Let's say 21 is FTP, right? And you can basically do accept, reject, and deny. Okay. In the book, it says accept, reject, and drop. Accept is just basically allowing. Rejecting is rejecting and notifying the sender. So which is good if, let's say, a customer is accessing a website and your website is down, you basically give them a reject status, or even, like, say they're not properly authenticated or they mistype something in their search, that gives them a notification that, hey, you were rejected. If it's drop, traffic is blocked at the firewall and the firewall won't notify the sender. So, because again, even sending a reject signal back to the requester, it also consumes resources. So if you're being, like, say, flooded with requests, such as denial of service attacks, it's better to put that IP to, like, a drop action, right? So that it doesn't consume resources. Yeah. Oh yeah, as Kendall said, drop unwanted traffic. Cool. And you can also log actions with various details. I think Windows users and Mac users have configured firewall, I think, even once, just because, let's say, you want something that's unsecured coming in, and you do want that for some reasons, and you basically want to disable your firewall. IP tables manages packet filtering and stateful firewall functionality, and does this through tables. And the tables consist of set of rules called chains. This is very important. Packet is compared to first rule. If no match, then moves to the next rule in chain. If match, moves on to the next chain, or is accepted, drop, or return. That's why chain. You chain them, basically. Each table has built-in chains. You can define your own. And you have something like this. In, let's say this one, the DMZ, the action is basically accept or let's say this protocol from anywhere to anywhere, right? And I think, let me just open up this quickly, because that one I think I saw in the exam, almost exactly the same, I think. Let me just open it up. Where was that? Student access. Yeah, this one. This one is an example of a chaining, so make sure you look at that and try to understand. It should be located in your student access performance-based questions, lesson 12. It should look like this. The first one should be easy. It's just IP tables. And you always have this IL and IJ or I. It's I, not L. Capital I and lowercase j. That's how you chain. And we can just quickly go over this. Let's say the first line creates a new chain called log chain. And the second line ensures all incoming packets not already processed by any prior rules will jump to log chain. The third line logs all package that reaches this chain. And the fourth line performs actual dropping of packets, as you can see. You can also substitute accept for drop if you only want to log accepted packets. Yep. Something that Jesse said, resources are not that important in this context. The less information you give an attacker, the better. Most attacks are attempted multiple times, and the attacker can modify his or her techniques based on information obtained from error messages. Okay, remember, look at this PBQ lesson 12. It will help you familiarize with the IP tables. Let's see. UFW is another firewall, uncomplicated firewall for Ubuntu, originally for Ubuntu. And you have following command. So it's always going to be like allow, like enabling the firewall, like allowing ports or protocols or IPs, disabling, also denying, rejecting. And Firewall D, it's basically a daemon, runs in the background, used to manage firewall dynamically. This comes with the system D. So you'd have Firewall D. The sysv init would have the IP tables. Applies to network resources, same rules. Firewall Cmd enables configuration of Firewall D. So you use this most of the time. Query, add, modify, delete zones. You'll use it regularly on RHEL-based distro, which is CentOS. And here's an example listing all of the zone. And some command examples. So get zones would list all zone, change interface, add service. add port, remove service, remove port, and basically you want to reload your firewall. Let's see, maybe you can stop here for now. Okay, try to follow along if possible. Say you want to manage your firewall service. First, you want to see the status, systemctl status, and firewall D. And this shows you your dynamic firewall daemon, if it's active or running. You can basically, if it's not enabled, you just put enable or disable or stop, right? Let's just spend a few minutes to check out the commands. So Firewall Cmd. So to do this, get zones. And you do have different zone: block, DMZ, drop, external, home, internal, public, trusted work for me. Let's see the default zone, public. So if you want to change your default zone, you do Firewall Cmd, get default zone. Let's say I want block. Something is wrong with what I typed. Set default, sorry, set success. So when I now see the get default zone, it should be block. Okay. Also, to check the firewall state first, do a firewall-cmd-state. And it says running, right? It should be, because we are able to do. So going back, so we changed the default zone, and we can also check active zones. There's none. We can create a custom zone to do our custom rules. I mean, you can customize rules as well in different zones. New zone, let's say test, and let's see firewall cmd get zones. And there's none yet, and we do have to reload. And now you should see your created one test here. So if you do want to manage your zone traffic, you do want to go firewall cmd get services. And this would give you a list of supported services. And I should see the usual ones that we always use would be just that one. HTTP, HTTPS, HTTP. And then the other one is SSH. So again, if you do want you do want to add a service to something, let me switch over to the test firewall. Say firewall Cmd, and then I think set default zone equals test. Okay, and then we can list all. There's none for now. And let's say we want to add our HTTP. We can do firewall cmd-zone, the one we want the test permanent, so it's stored to disk instead of the RAM. And HTTP. We can also use this to list services, right? It doesn't show here, but yep, it should show here. You can add another one. SSH. Okay, now what if we want to check if we're running IP tables? So again, it's basically if you want to use IP tables, you might want to just disable your firewall, right? And the way to do that is first you do want to maybe stop it with firewall D, and after you stop it, you do want to mask it. So why did we mask it? Because maybe there's a dependent service that could still start your firewall even though you stopped it, right? So masking it would basically not allow a way to enable it again or start it again. So as you can see, created a symlink service and to dev null, right? To nothingness, to the black hole. And we can check if we can check if we can see if we have IP tables. We don't have, so let's see if this is something that's nope. So let's go back to the IP tables quickly for a while. Let's see if we can install that. System yum install Oh, maybe wait. Maybe I don't have access to stuff, to the internet, just because I think I recreated my stuff before. No, could not retrieve. Maybe a search. Maybe I have to upgrade it again. I'll just configure this next time. Yeah, you can say like freezing it. Yeah. Because again, other applications could start that stop firewall D. Well, maybe just to show you some of the commands that I can't show the output to is if you want to enable IP tables, you do something like this. And you can also use the systemctl enable -- now IP6 tables as well. And if you want to see the list and next the rules, it's as simple as the -- list, and then the rules should be tables list rules. Again, we do have 3 chains. Again, the input, incoming traffic. Most of the filtering is performed. Forward is the routed traffic, not used on most machines, typically used for routers and firewall. And the last one is output, outbound traffic, so we don't really filter out outbound traffic. So net filter, firewall D, IP forwarding. This is best to go back to after you guys finish the networking class. I mean, there's only two courses for those. IP sets, you can skip this for now. Firewall, troubleshooting, block ports, restrictive IPS appliance, deny host, fail to ban. These are things that you can just read, because I don't think, let's see, yeah, there's not a lot of examples with those as well, with the fail to ban. So I guess we can do quick system logs for the remaining time. So sys logs, you basically record system activities, right? And syslog facilitates a centralized logging, and you can record text files and syslog entries of date, time, process name, ID, and message. And your log file locations are there. I think we've visited this several times as well. So and you do have those logs. So syslogs, all system events, message, non-critical events for RHEL, Debian, and you have auth.log for RHEL. You have secure, current, kernel message, and virus applications. So here I do have also the firewall D. Let's see if we are able to check firewall D. Oh no. Nothing is in there. Last log. Let's see. We do have something. Let's say secure. Because I need the log stuff. Sorry. So this is the secure. Authentication agent. The logins. Log rotate to do automatic rotations of your logs. Create new version of the log files and maintain a minimum log file size. Our syslog improvements to old syslog service and supports the following. Let's quickly browse through this and let's go back to the terminal. etc rsyslog.com for configuration file. What files to write to, what users to print message to, remote host to forward message to. It shows like this. So we also have the journal CTL view and query logs created by the Systemd journal. Journaling is again the process of temporarily saving your objects so that if you get interruptions, you can basically retrieve from that state. And then again, don't forget, if it's trying to save to that temporary state, while it's saving, it gets interrupted, you also lose that temporary save. So journal CTL to see journal messages. So these are like some of the commands you just have to familiarize yourself to see what it kind of looks like, right? Last, we also used this before. Shows you the user in the teletype terminal. One is still logged in. It basically retrieves info from your var log wtemp. Last B does the same, but for failed attempt. None. Login, logout events, logging services, examining log files, backup types. So for backup types, we do have different backups. We have the full, differential, and incremental. For differential, all files that have changed since last backup will be backup basically. It uses less storage space and backup time than full, slower to recover. Incremental, basically all files that have changed since last backup, less time to perform than differential, and slowest to recover. And we did use the tar command before. This is a tape archiver, originally developed for tape and can be used with any media. Again, this is a archiver. So you can basically supply many file objects there. And the C and F is, C is basically create tarball, and the F, CF, create archive tar files from, create archive.tar from files, basically, the CF. Copy in, out, copy out, copy files into an archive, copy files from an archive, copy files from one directory tree to another. DD converts, copies and converts files. Mirror VG copies logical volume. Offsite backup. Data transfer tools to securely transfer or copy. SCP for secure copy. SFTP uses SSH tunnel as a transport mechanism to make it secure. rsync is another, checks the file differences. It can use SSH or rsync Daemon. Let's quickly check on stuff. Compression. Compression is reducing your file size, making storage transfer data more efficient. Compressed data can either be lossless or lossy, and this comes up many times with your MP3 files. The gzip, we also used this before, compresses and decompresses .gzip files. Similar to gzip, so this one is XS. Bzip, multiple commands for managing compressions. As you can see this most of the time that an archive gets compressed, okay? Because archiving does have some form of compression, but doesn't really reduce a lot. So that's why if you want to archive, you can archive first and then compress. Zip, compression, and archiving. So which to use? This is just something that you have to remember, right? gzip when time is the biggest factor, xz when storage space is the biggest factor, bzip to strike a balance. But just knowing one should let you know the underlying concept. It should be fine. Compressing files, integrity checking, so checking the checksums. Hashing is common. Compare hash value to pass value. No change in hash means no change in data. This comes back to the very beginning. If you put a text and then you put it in a hash function, it should generate a digest. If you put the same text, put it in the hash function, it should generate the same hash value or message digest. This could be kind of different when you now do some compressions, and it does change the hash value, and you just have to put some options so that it would not include, let's say, timestamp of that file. Oh yeah, hash functions, you do have the MD5, the SHA, more secure than MD5. So you do have the 256 and 512. These are the more common ones that we see. MD5 sum command calculates hash value of a file. You can quickly check that if it's oops, MD5 sum. Let's see if I do have it first. Yes, I think I have it. Let's see, what do I have here? So it will basically show the hash for that one. Calculate the hash value for that file or directory or file, sorry, or a file. And then you have the different SHA commands, the 1, 256, 384, and 512. Okay, so we go over to some commands. So we've done archiving, so we can just not do that, I guess. If you do want to copy a disk to another disk, your command should be like this. Let's say your dev SDA to off dev SDB. So if you want to make an image of a disk, you can basically do. So this is again when you're trying to back up the disk, right? SDA off equals drive underscore image. Basically any image file name you want. And if you want to restore the image to a disk, so the first one was copying it to another disk. The second one is making an image of the disk. The third one, which we're going to do, is basically restoring it. So let's say you have the drive image.name and you want to put that in this partition. So that's how you go about restoring an image to a disk. Okay. Let's see, what else? So I do recommend that for the next course, when you're doing your team project, you can go and basically do a team project about IP tables, Firewall D, or backups. Backups, they don't really go too deep actually. But I think what I saw with the backup is just copying files really, and maybe copying the log files to a directory, like a very simple backup. Again, now it might seem a bit muddy, especially with the networking stuff, but it will become clearer. Just so you know that we went through the intro to cybersecurity and the CH root jail. Let's see my notes. CH root jail, so create a boundary and can go to the rest of the system. If there's an attacker, you did file auditing, and Always it's in etc for the configuration of anything that you're looking for, right? And the rules would be in rules.d. Logging files are in var log. Talked about encryption, hashing to ensure integrity. It's not really encrypting, so you can break hashing as well, but it requires a lot of resources to break it, a lot of computational power. We showed you the LUX disk encryption. If you want to encrypt a disk, right? So to encrypt a disk, you first have to mount, then you have to set up to the LUX format for that disk. Before that, you should shred it. You shred it first, delete the data, unmount, shred it, and then once you're done, you can now create the file system again and mount that, and now you can copy it. You can copy stuff now to it. Copy stuff. And encrypted data at rest. SSH is a service daemon, okay, kind of like your HTTP with Apache. Basically, you want to secure your server and secure your client at the same time. Changing your port number doesn't really help. Changing your configuration, just don't forget etc. Without the D is the client side, with the D is the server side. You can define the protocol that you want in the config so that it will not allow SSH1. Changing port number, but does not really help at all. Always don't forget to restart your service if you made changes to your config. We talked about where the keys are, still in the SSH. We have 3 types of encryption algorithm, and these are the RSA, ECDSA, and ED25519, and we deleted them and generated the keys again with the keygen command. Okay, and whatever encryption algorithm we want, and where do we want to store it with a name. Don't forget to keep the same name so that your SSH service configuration would know it. Restart your service as always. The fingerprint. So again, don't need to distribute the public key. Distribute the fingerprint instead. You could also send the fingerprint to their known host. You can also put that in your etc scale so that new users would also have the same known host. Key scan, which we did not did, but it's basically you can point to a server to grab the public key and put that in your host file. And you do want to use the greater than instead of one greater than, so that you append and not overwrite. So this one we did not go through because we don't have a known host, but basically inside that you could again make configurations to ask you before trusting it or not. Let's say a server, right? SE Linux is for CentOS and Rails. Oops. Important parts here is the disabled, permissive, enforce. Biggest one is permissive, so it will allow unauthorized access. Okay. Good for testing out application. If it touches something that is not authorized for, it will be logged. And then you can prove those which are safe, then use enforce. To see the status, SE status. To check, to different, change your enforcing or permissive. You can use 1 or 0. To make it permanent, put it in the config file SE Linux example permissive. And the capital Z to your ls or ps shows the SE Linux labels, which we do have the user roles and type. RestoreCon helps you a lot if you messed around with your SE Linux policy and you don't know how to change it back. You just do RestoreCon. AppArmor, similar to Ubuntu. I mean, it's for Ubuntu, similar to SE Linux, sorry. The difference with this one, it uses file paths again and profiles, but you can basically do the same thing like complain, which is like permissive, and basically enforcing. So firewall, you get to start, enable a service. Again, it's a service. You can get the zones, change your default zone, and you can add basically different services like HTTP or HTTPD with this one, right? And just so you know, like in firewall, without the -- permanent, it will be stored to RAM, which is good in a sense so that you already have that. Let's say you added the HTTP and that's added to the configuration. -- permanent makes it persist so that it's stored in the hard disk. That's why we have to do both, because if you just do the hard disk, you have to reboot first for it to take effect. So that's why you can do without permanent first so that it takes effect and it's in the RAM, a temporary memory, right? And you also save it in permanent so that when you reboot next time, it's there. So IP tables as well, if you just use one or the other, right? So either disable IP tables or firewall. And you do have to learn about like chaining, very important. Then last part is the backups, because we went through most of these already, like zipping, archiving, backing up, and this time around is just with disk and different types of backup, like incremental, right? And just go ahead and go through some of the labs again, so it kind of helps you with that. And again, the performance-based question, and it is now 12, and so I hope it was not too much. It was like a lot of topic as well, but we'd like to move on and stay on track for now so we can touch on other topics. If Friday we did finish early, we'll try to get back to some of the topics and maybe get more examples, hopefully with IP tables. That would help a lot because we did not really show examples with IP tables. So let's check on Friday. Okay, if nothing else, let's have our